All right, so our topic for today is properties of logarithms. And before we start, I'm just going to say that this can be a challenging section, but probably good that we have a video of this topic in case you need to review any of these concepts. They can feel a little abstract until you've practiced it enough to feel confident with these skills. All right, so first we have three different properties. Let b, m, and n be positive real numbers, and then the base of each log, it can't be 1. All right, so first we have the product property. Log base b of m times n. What's in the argument position is a product, numbers being multiplied. We can break this apart into two smaller logs. We can express it as log base b of m plus log base b of n. So we can break apart the products and write it as two separate logs with the same base, joining them through addition. Let me give you a mini example here. So if I said log base 3 of, let's say 27, but I'm going to make that 3 times 9. Again, we know that that's 27. I could break that apart and say, oh, that's log base 3 of 3 plus log base 3 of 9. So just to show you how that works, we know that log base 3, let me write the 3 in there, log base 3 of 3 times 9, log base 3 of 27. 3 to the third power is 27, so this cleans up to be 3. 3 to the first power is 3, so 1. 3 to the second power would get us 9, so 2. And 3 does equal 1 plus 2, so that's a true statement. Okay, next is the quotient property, just a fancy word for fraction. So log base b of m over n. Here I can split them up using subtraction. Log base b of m minus log base b of n, like that. Again, let me give you another example. Let's say that I had log base 3 of 3, but I'm going to write that as 9 over 3. We again know that that cleans up to be just 3. Okay, then I could write it as log base 3 of 9 minus log base 3 of 3. So log base 3 of 3, right, 3 to the first power gets us back to 3. 3 to the second power gets us back to 9. And then 3 to the first power gets us back to 3. And 1 equals 2 minus 1. That is true. Okay, lastly is the power property. So if I have log base b of m to the n power, that exponent can pull out in front, and I can write it as n times log base b of m. So again, another little mini example here. Let's say that I had log base 2 of 8 squared. Okay, that 2 could pull out in front and be 2 times log base 2 of 8. Okay, so log base 2 of 64, let me slide that over, would end up simplifying to 6, right? 2 to the 6th power gets us back to 64. And then over here we'd say, well, that's 2 times log base 2 of 8, right? 2 to the third power gets us 8, so a 3 right there. And 6 does equal 2 times 3, so that checks out. So with a product, when we see the argument has terms being multiplied, we can split it up into separate logs using addition. When we see a quotient, a fraction in that argument position, we can split it up using subtraction like this. And then the power property says if we see log base b of something that has an exponent, that exponent here on the m, on that value, right, can pull out in front and be a multiplier instead on the log. All right, so this is really an exercise in structure, making sure that we can see this structure and apply it. So first up, can we express each sum as a single logarithm? So I have log base 2 of 2 plus log base 2 of 4. That becomes log base 2 of 2 times 4, or log base 2 of 8. Now I can simplify that because I know that 2 to the third power gets us back to 8. So log base 2 of 8 really simplifies to 3. No more log. Okay, next one. They're both common logs because there's a base 10. So really we have log base 10 of 1/10 times 100. Log base 10 of 10, right? We know that that simplifies to be just 1. And you don't have to write the base there. We know that it's there, right? Even when we don't write it, it's a common log. Okay, next up here, log base 3 of x plus log base 3 of x minus 9 as a package in parentheses. So I have log base 3 of x times x minus 9. Distribute the x. Log base 3 of x squared minus 9x. But I need to put parentheses back so that whole chunk reads as the argument. And then that's my final answer. Okay, one more. I have log base 6 of 5 plus log base 6 of x plus 2 plus log base 6 of 4. It's all being multiplied. So I can go ahead and take log base 6 of 5 times x plus 2, right, times 4. All these different parts are being multiplied. So I'd probably think of it as log base 6 of 20. I'd multiply those single terms first and then distribute over the x plus 2. So log base 6 of 20x plus 40. Again, parentheses to keep that as the argument. So all of those are examples of the product property, right? Where we know that we can take two terms that are joined by addition and fuse those two arguments together using multiplication. Okay, next is really using that quotient property. So here, these terms are joined by subtraction. So I could say here, log base 2 of 8 divided by 2, just like that, which is really log base 2 of 4. And I can simplify that because I know that 2 to the second power gets me 4, becomes just 2. Okay, another one where they're joined by subtraction, common logs again, base 10. So really log base 10 of 1,000 divided by 10, or log base 10 of 100. We know that 10 squared, 10 to the second power gets us 100, so ends up simplifying to 2. Okay, here, again, same base, so I could say log base 9 of x over 5. And then another one here, again, joined by subtraction. So I could say log base 4 of x to the third power plus 4 divided by x squared plus 5. Now there's nothing I can do to simplify because I have a binomial over a binomial and there's no common factor between them to simplify further. So that's as simplified as I'm going to get. Okay, lastly is just practicing that power property. So here we would take the exponent, put it out in front. So 5 times log base 3 of x. Here it's written as a root. So if I first just rewrite that as log base 7 of 5 to the 1/2 power, now I can pull it out in front. Half of log base 7 of 5. Okay, the -2 comes out front, so -2 times log base 4 of 6. Okay, here again it's a root, so I'm going to rewrite it in exponential form, x to the 1/4 power, and then that 1/4 comes out in front. So 1/4 log base 5 of x. All right, so we're good on the first page. Let's flip it to the back. All right, so next here, I'm giving you that log base 2 of 5 is about 2.322. Log base 2 of 12 is about 3.585. And we want to use this to evaluate each logarithm. Okay, so here if I look at that 60 right here, I think, well, can I use a base of 5 and 12? Can I use here, or a base of 2 here, but can I use the product of 5 times 12 to get me to 60? Could I think of the factorization of 60 in terms of 5s and 12s? Well, of course. I know that log base 2 of 5 times 12 is the same thing as 60. So now I can split it up and think of it as log base 2 of 5 plus log base 2 of 12, which then means that I'm taking 2.322 and adding it to 3.585. Which will get me about 5.907. Okay, here in B, I have 1 over 44. Well, 144 is really 12 squared. So again, I'm trying to think, how can I use the 5 and the 12 in the argument position, right, to simplify it? So log base 2 of 1 over 12 squared, okay, which is then going to split into log base 2 of 1 minus log base 2 of 12 squared. And I could pull that exponent of 2 out in front, right? This is the power property. Log base 2 of 1 right here, well, 2 to the 0 power gets us back to 1, so this is really 0, minus 2 times, right? It's going to be 2 times log base 2 of 12, which I know is 3.585. So I'm going to end up with about negative 7.17. Okay, next one here, log base 2 of 12 over 25. So I see the 12, right? That's helpful. And 25 is 5 squared. So first stage, log base 2 of 12 over 5 squared. So log base 2 of 12 minus log base 2 of 5 squared. And again, that 2 can pull out in front. So using the quotient property and the power property. Okay, and then I have 3.585 minus 2 times 2.322. Okay, and that's going to get me, in the end, 1.059. Okay, and then lastly, log base 2 of 720. So staring at that 720, let's see, that's 5 times 144. 144 is 12 times 12. So maybe I think of it as log base 2 of 5 times 12 times 12. So I'm going to use the product property here and then look at it as log base 2 of 5 plus log base 2 of 12 twice. Slide that over. Okay, so then I really have 2.322 plus I have 2 of 3.585. Okay, and if I add those together, add them up, I get 9.492. Okay. Often we have you use these properties to expand and condense. So over here, I see that it's one singular natural log, and I want to expand it. So here, the first step that I would do is I would break it up into natural log of, I'm going to use the quotient property, 5x to the 7th minus the natural log of y. Okay, And then I'm seeing that right here, that's a product right there. That's two terms. So I can split that up. Natural log of 5 plus natural log of x to the 7th minus natural log of y. Last thing to do is pull the exponent out in front, and then I am fully expanded. Okay, that would be my final answer. Okay, we also have you condense. So if we give it to you in expanded form, can you pack it back together into a single log? So here I'd probably put the 3 back into the exponent position first. So next stage I have log 9, right? So base 10 plus log 2 to the 3rd power minus log 3. Again, all common logs, there's really a base 10. So now if I fuse these two together, because I know that's really an 8, that's log 9 times 8 minus log 3. So log 72 minus log 3. Okay, so now with subtraction comes division. I use the quotient property, and I get log 72 over 3. So log 24. All right, so those are all of the core skills, but I think it's useful just to see a little bit more. So all of the ones at the bottom are just meant for extra practice to reinforce this very abstract skill. So again, not going to lie, I know this is a little harder because it's pretty abstract. All right, so let's practice. We're in practice mode. So log 10x, so 10x is the product in the argument position. So here I'm going to go ahead and use the product property and write this as log 10 plus log x. Again, I know that the base is 10 even if I don't write it, so that shows me that right here I can simplify. I know that 10 to the 1st power is 10, that goes to 1 plus log x, and that's all I can do. Often I have students who just think, is it done? Did I get to the right conclusion? That's why we give you the answer keys so you guys can check your work. All right, next one here. So here I want to expand it. Here I see a product in the argument position. So I use that product property to split it up. Natural log of 2 plus natural log of x to the 6th power. Pull the 6 out in front, that's the power property. Natural log of 2, ln 2, plus 6 times natural log of x. Okay, that's it. Nothing else to do. Okay, next one, log base 3 of x to the 4th over 3y to the 3rd. So first I see that fraction bar, it's a quotient. So I'm going to split it up, log base 3 of x to the 4th minus log base 3 of 3y cubed, right? That's all in that argument position. I can then see that since that's a product, I should split that up too. So log base 3 of x to the 4th minus, I'm going to say in parentheses, log base 3 of 3 plus log base 3 of y cubed. Okay, so again, the reason I put that in parentheses is because that product of 3 and y to the 3rd is together on the bottom of the fraction. So I need to make sure that it keeps it in the bottom, so I'm using parentheses. Okay, anything in the exponent position pulls out in front. So here I'm going to have 4 times log base 3 of x minus parentheses. Well, log base 3 of 3 I can simplify. 3 to the 1st power is 3, so 1. And then plus 3 times log base 3 of y. Okay, now I would take your final answer like this. This would actually be fine with me. It would also be okay, or you distribute that -1 to both of the terms. You could leave it like this as well. So 4 times log base 3 of x minus 1 minus 3 times log base 3 of y. Both of those would be equivalent, would take it either way. All right, last one here. I'm seeing it in root form in the argument. So first things first, I'm going to go ahead and make that exponential 1/4 power like that. I'm going to distribute that 1/4 to both terms. So natural log of 3 to the 1/4 power, or quartic root of 3, and then y to the 1/2 power. Okay, so now I can split that product apart. So ln 3 to the 1/4 plus ln y to the 1/2. Okay, and then I pull those exponents out in front. So I have 1/4 of ln 3 plus 1/2 of ln y. And that is as simplified as I'm going to get. All right, so the more practice that you have in checking the answers is super helpful. Okay, lastly, can you condense? Can you pack it all into one log? So here we see that we have addition. So we take those two arguments and we multiply them. So I'm going to end up with log base 2 of 24. Okay, over here, I have log base 5 of 4 minus 2 times log base 5 of, or log base 5 of 5, right? So that 2 should go back into the exponent position. So right now I have log base 5 of 4 minus log base 5 of 5 squared. So then I'll have log base 5, right now it's subtraction, so that becomes the quotient property, where I'm putting 4 over 5 squared, which would be 4 over 25 in that argument position. So log base 5 of 4 over 25. Okay, next one, I can see that that 3 goes back into the exponent position, but it has to apply to everything that's in the argument position, so the 6 and the x. So ln, parentheses, 6x, close parentheses, third power. Again, that 3 distributes to both, plus natural log of 4y. Okay, so distribute that. ln, I have 216x to the third, right? I can put parentheses around it or not. It's still in the argument position, plus ln 4y. Okay, so that addition here, if I want to fuse it into one term, I can multiply their arguments. It's the product property. So ln, I'm looking at 216x to the third times 4y. So I'm going to end up with ln 864x to the third times y. All right, one more row. Okay, so first thing that I would do, if I look at it, I'd probably put the 1/3 back into the exponent position. I see that I'm subtracting and adding, so if I read it from left to right, first I'd say log base 2 of 625 over 125, right? With subtraction comes division, that's the quotient property. And over here I now have log base 2 of 27 and 1/3. Same as saying the cube root of 27. So now log base 2 of 5 plus log base 2 of 3, right? Cube root of 27 is 3. And then I see a plus joining these two logs. So log base 2 of 5 times 3 becomes log base 2 of 15. That is as simplified as I'm going to get. All right, one more. So in E here, let's see, I put the -1 back in the exponent position, and same with the 2. Again, that's going to go to the entire argument of 3x. So right now I have log base 6 of 6 to the negative first minus log base 6 of 2y plus log base 6 of 3x quantity squared, like that. So 3x is in parentheses squared. So that exponent goes to both terms right there. So now next stage, right, I see subtraction, so I can join the arguments with division. It's the quotient property. So log base 6 of 6 to the negative first power over 2y plus log base 6 of 9x squared. Okay, so now if I think about that 6 to the negative first power, that's really 1 over 6. So I really now have log base 6 of 1 over, right, 6 times 2y, right? I'm just going to say that's really 12y, and then plus log base 6 of 9x squared, which becomes log base 6 of 1 over 12y. Since I'm adding them, I'm going to multiply the arguments, so times 9x squared, right? It's like it's over 1. So then I have log base 6 of 9x squared over 12y, and I can do one more thing. I can simplify the 9/12. That's going to become 3/4. So last step, final step of the day, log base 6 of 3x to the second power over 4y. All right, so hopefully this video lecture gave you a lot of examples. We will definitely circle back when we see you in class next week. We know that this is a harder skill that we need to practice together a little bit more for you to feel confident. All right, have a good rest of your day.